Hello, this is Mr. White, and this video is on function transformations, and specifically how rearranging the order in which we apply a series of transformations will often affect the final function that we end up with. So by now you should be comfortable with the following transformations: translations, reflections, and stretches and shrinks, which are summarized on page 132, 135, and 137 in the 6th edition of our textbook. And in this example, we're going to start with the basic function f of x equals square root of x, and we're going to apply the 4 transformations that you see here, first in the order that you've seen, and then again in a different order. So let's start with that reflection across the x-axis and just get a sense of what this is going to look like before we get into the algebra. So reflection across the x-axis should be a mirror image with the x-axis as the mirror, and it should look like this. In the second transformation, we're going to translate it up 2 units. So every point on there would move up 2 units and look like this. We'll then translate it to the right 1 unit, and I should mention at this point that while you're doing your homework with transformations, I think for a lot of students it would be very helpful to use graph paper and really sketch out what we're dealing with here. I would be willing to give you some graph paper if that's what it takes for you to do that. And in our final transformation, a horizontal stretch by a factor of 2, I want to slow down a bit and make sure everybody catches a little distinction here. I think it's very common for students to think that when we stretch it, that we're going to stretch it around this vertex point. And therefore, it'll stretch and get skinnier, but still have that same vertex point. And I need to alert you to the fact that that is not the case. When you horizontally or vertically stretch, for that matter, you are always stretching with respect to the y or the x-axis. So in this case, this horizontal stretch by a factor of 2 means that, again, focus on the green graph here, that this point, which is currently a distance 1 away from the y-axis, needs to be stretched to a distance of 2 away from the y-axis. This point, which is currently a distance 2 from the y-axis, needs to stretch a distance of 4 away from the y-axis. Notice that the y values are staying the same. It's only the x values that are doubling, that are being multiplied by a factor of 2. This point right here stretches to, that's 5 units away right now. It goes to 10 units away. And so in appearance, it may look like this has been a translation and a stretch, but that really was just a horizontal stretch going from the green to the black graph. So let's now take a look at the algebra here for those transformations. We start with the square root of x, and to reflect it across the x-axis, we put a negative sign in front. So right now, let me highlight that. We are doing the reflection across the x-axis, and we do that by just putting a negative sign in front. Now let's do the translation up 2 units, and that one I think most of you would go, yeah, I know how to do that. We just tack on a plus 2 at the end here, right? Then we're going to translate right 1 unit, going to the green graph here. And you may remember, I hope you understood in the class discussion why this is counterintuitive. You're not just memorizing, you're understanding why this is. So we replace that x, we erase it, and we replace it not with x plus 1, which our intuition would tell us, but with x minus 1. And then finally, the horizontal stretch by a factor of 2. Again, that's another horizontal transformation, so I would say that clues us in that it's counterintuitive. We erase the x, and our intuition would tell us to replace it with 2x, but we don't. We replace it with a 1/2 x. And that is our final function. I don't want to call this f of x anymore because f of x is given up here. So I'm going to give it a different name. I'm going to call it g of x and say that that is my final transformed function. I forgot to move the highlight. We've done our horizontal stretch by 2 now. And so this is our final transform function that includes all 4 of those transformations. The final graph on the that we are left with is the black graph over here. Okay, so let's do those same transformations, but in a different order. So again, starting with square root of x, but this time let's do the translation up first, and then let's do the horizontal stretch by 2, followed by the reflection, and finally the translation to the right. So again, let's look at that graphically first. If we translate this up 2 on the graph, that would be our translation up 2, and then we'll do the horizontal stretch by 2. Okay, there it is, magically appeared on the screen. And again, what I really want to highlight is notice that when I go from this red point to this black point, it is twice as far away. This red point goes to this black point, which is twice as far away as the red point was from the y-axis here. Then we're going to reflect that across the x-axis, and I caution you once again, it is very tempting for students to think that when you reflect this black graph that it's just going to look something like this. But notice that's not across the x-axis. If it's going to be mirrored across the x-axis, these points need to show up as follows. And finally, a translation of 1 unit to the right. Each one of those points moves to the right 1 unit. And there is our final graph. So now let's do the algebra. Our first move was to translate up to the basic function square root of x. So we do the plus 2. And then to do a horizontal stretch by a factor of 2. So remember what the rule is on that. Take out the x and replace it not with 2x, but with the counterintuitive 1/2 x. Reflected across the x-axis, let me slow down because here is where a really easy mistake could be made. If I want to reflect it across the x-axis, that means that all my y values that used to be positive are now going to be multiplied by -1 and become negative. So if I turn to the graph, for example, if I have a point up here and it gets flipped across the y-axis, actually that's a bad example, let me say right here, and it gets reflipped across the x-axis, it ends up down here. So the x value stayed the same, but the y value got multiplied by -1. So with that in mind, keep in mind that our expression here is a y value, and when we multiply it by -1, we need to put it in parentheses and multiply the entire thing by a negative. That is a major point. Don't just multiply the square root of 1/2 x part. You got to multiply everything by -1. And similarly, for this translation to the right by 1, it would be a big mistake to, let me just clear myself a little room here. It would be a big mistake to just do, oh, I'm going to put in x -1 to move to the right. I hope you see the mistake that I'm making here. I needed to erase that x and replace it with parentheses x -1. I'm trying to go fast here because I don't want this video to be any longer than it needs to be, but I do worry that I'm mentioning some subtleties that may leave some of you confused. So please take some notes if you're, note where you're getting confused if I'm losing you. Replay if that doesn't help. Come see me during office hours, please. As I said in the last example, I don't want to call this f of x anymore. I need to call it something different. We called the last graph g of x, so let's call this one h of x. And that is our final transformed equation. And I'll remind you that our final transformed graph was this green one right here. So compare and contrast with the previous page. I'm going to flip back to the previous page. So look at that equation and look at this one here. And I hope you've written it down on paper so you can see both of them in front of you at the same time. They are two different graphs of two different equations. And if I were to check this on a calculator, you would see, I'll put the names that I gave them up here. I called this one, I believe, g of x, and this one was the h of x. Here you see them on the same page. You see that they are similar, but definitely not exactly the same equation. We've got We've got a plus here and a minus here. We've got a 1/2 on the top that did not get distributed this one. The 1/2 on the bottom did get distributed. So make sure you see those differences and understand that that's what led to these two different graphs, which do match the ones that I was sketching in the previous slides. So your turn to try. So here are, you're going to be dealing with the f of x equals x squared basic function, the squaring function, and you're going to do this set of transformations, and then followed by this set, which is really the same transformations, but just in a different order. So pause the video, and let's see what you get. Okay, I'm assuming you have done this exercise on your own, so let's compare to what I have. Rather than just flash the answer up here on the screen, I'm going to go ahead and work it out real quickly, just so in case you made any mistakes, you can have a better chance of finding out where. Notice the color coding on the screen of the graphs reflects each of the individual transformations. So let's start with the algebra. If I start with an x squared, and I want to translate it to the left 3 units, I will erase the x, and I will replace it with the parentheses x plus 3. Remember, counterintuitive. Left seems like it ought to be minus 3, but it's actually plus 3. If I want to reflect it across the y-axis, that means that any point over here on the gets mirrored over here. Notice that the x value changed, not the y value. The x coordinate changed, not the y coordinate. Therefore, we come in here and we replace the x, we erase it, and we replace it with a negative x. That was our reflection across the y-axis. Now we're going to translate it up 1 unit. So I do a plus 1 here. And finally, a vertical stretch by 2. I caution you to the easy mistake to make. Again, it would be easy to do this and think that you got it, but remember, it needs to be 2 times everything. The entire y value gets multiplied by 2 for this vertical stretch here. And that would be our final function. I've already used g and h in this video, so let's call this one, I don't know, j of x, just for kicks. If you want to neaten that up a bit, if it makes you feel better, go ahead and distribute that too. You certainly don't have to, but if you wanted to write this as negative x plus 3 squared with the 2 in front, and then a plus 2, if you want to distribute that too, you may do it either way. Just be sure that you do it one of those 2 ways. And avoid the temptation to take this 2, avoid the temptation to move it inside the parentheses. Notice the parentheses are being squared, whereas the 2 is not being squared. So you do not want to move the 2 inside the parentheses. Okay, that should be your final answer for that one. Now on to this one, the second half. I'll move it up to leave myself a little space here. You're doing the same transformations in a different order. I'll go ahead and name this one off the bat. The last one is j. This one will be, let's say, k of x. Why not? Okay, we'll start with the vertical stretch by a factor of 2. So I'll take that x squared. There's not a whole lot to be multiplied by 2 here, so I don't have to have the parentheses. I could put them, but I don't have to, so I'll put 2x squared. Let me put the highlighting back up here. We just did the vertical stretch. Now I'm going to translate up 1 unit, plus 1. Now I'm going to reflect across the y-axis. Again, the x gets replaced. It gets erased and replaced with the negative x. And if you look real carefully here, when I erase the x and replace it with the negative x, you may be thinking, wait a minute, it's being squared, so that negative sign is going to go away. That's true. I'm going to go ahead and keep it here just as a formality, but that negative sign really we're going to find has no effect. And likewise, if you look at the graph at this point, if you look at the graph, you notice that the graph is symmetric about the y-axis. It's an even graph at this point. So reflecting it across the y-axis, again, graphically doesn't make any difference. Again, I'll keep that negative sign in there just as a formality. Our final move would be to translate this to the left 3 units. So let me clear myself a little space here. And remember the rule for that. Erase the x, replace it with the parentheses x counterintuitive plus 3. And so that could be your final equation for k of x. If you want to clean it up a little bit, you could, as I mentioned already, really ignore that negative sign. If you want to clean it up a little bit, again, that negative sign is being squared, so it goes away. And we could just write, if you want, 2x plus 3 squared plus 1. So again, I rushed through this one a little bit because otherwise it was going to be half an hour long. But I hope you understood it. If you didn't, please come on by to office hours and get clarified whatever it is you may have missed.